My name is Kashif, and I will be your moderator today. And I have with me Andy Idsinga, who's a senior strategic cloud architect at cPacket Networks. Hey, Andy.
Hey, Kashif. Hey, everybody. Good to be with you today.
Perfect. A quick intro on our company. cPacket Networks is a leading provider of best-in-class network visibility solutions to de-risk and optimize your IT infrastructure and operations. The attendees will also get an opportunity to learn more about cPacket during our session.
All righty. I'll go ahead and get started with the presentation here. Start with this slide. Kashif, why don't you kick us off on some of the stats and the kind of the why for the whole thing, why we're even thinking about this and what's happening.
Sure, Andy. Getting started here, what we have all been seeing is that network observability is getting more mainstream attention, more momentum in recent years. And some of the major trends, driving this need for observability is digital transformation, evolution of applications and services for business success, and the massive shift we are seeing towards cloud adoption. As businesses are looking to achieve more scalability, flexibility, and global connectivity. But Andy, on the flip side, most of these trends are
Right.
also leading to bigger impacts, such as increased complexities of operating a service across multi-cloud environments, and also the high cost,
Right.
associated with a service outage when it happens. And so, Andy, as we know, the need for observability has become real. But why should companies start to take
Yeah,
more
I mean,
take this
as you
more
can
seriously
see
now?
in some of the infographics here in front of you, the really big use cases are security and operational incidents that are occurring. Right, cloud deployments are really growing rapidly, often taking organizations a little bit by surprise in terms of how fast they're growing, and the costs and the kinds of incidents that are occurring. Right, and so people, as IT teams are struggling to kind of keep up with this, they're looking for better tooling that are going to help them really reduce the time to solving incidents, right? Understanding those incidents quickly, and then gathering together the right people with the right data in hand right away to be able to solve those incidents, working with the cloud providers themselves, right, to help solve these. So this is something we see happening. They're reaching for tools that are provided by cPacket and our security partners, and they're looking for faster incident response times, right, and better data management and analytics to go with that. Some of our customers are managing 3,000 virtual networks up in the cloud, right, and tens of thousands of network nodes. So this quickly becomes an unmanageable problem, and they need the kinds of tooling that are designed for the cloud and designed to scale in the cloud, and work with cloud lifecycles, right? And it's a little bit different than the data center, right? The constraints of physical data center approaches to racks and nodes and taps are quite a bit different. Those constraints are gone in the cloud, and people are able to rapidly expand their usage of the cloud. The other thing we see that's very closely related to this is the organizational dynamics in the cloud, right? Companies aren't just having their IT teams develop the whole cloud infrastructure. Often application teams are building out, VPCs in the cloud, virtual private clouds, virtual networks, deploying their applications. And then as problems start to occur, or as the rest of the IT organization catches up, they have to then build out tooling. So in this presentation, we're going to touch on approaches to tooling, talk a little bit about some of the experiences we've seen, and talk about the solutions that are available in the cloud. All right, let me head over to slide 3 here, and I'll just go full screen at this point. So tell us a little bit about some of these things, Kashif.
Sure, Andy. So this is a great set of data points of what is happening more recently in the real world. And Andy, the key takeaway here is that we have seen a rise in service outages, but another trend we are seeing is that these outages are also lasting longer, and in some cases, many days at a time. If you look at the example of Y-Star Credit Union, earlier this year, Y-Star's mobile banking crashed and was not accessible for 10 days. thousands of clients had no option for online banking other than to physically visit their branch to perform basic transactions. And one can imagine how disrupting that can be. And Andy, just curious, what are your
it
insights
is
on
really
these
interesting. We've been
trends?
monitoring a lot of these kinds of service outages, right? And that's where we've gathered together some of these headlines, right? We do see these things happen. They're not necessarily going down in the total volume, right? They're just sort of constantly happening. And what we're seeing is IT teams who are coming up to speed on the cloud and really having a lot of frustration with figuring out where problems are, when incidents do occur, how to then communicate with the stakeholders involved, usually the application owners, and also getting support from the cloud providers, right? So this is a real issue, and being able to have a good idea of what's happening on the network, what's happening with the tooling, and having the right data in hand is really key to reducing this. The other thing too is that these headlines are eye-opening a little bit, and they definitely affect customer perceptions, right? The public's perceptions, but they also affect morale on the teams, right? When they don't have the right tools or things are frustrating and slow. I've talked to customers who have low-level issues happening with applications that take days and weeks to get resolved, and it's just a frustrating experience because of the kinds of data that are required. I have customers who have network issues, and when they talk to tech support, they're asked to capture packets right from the instances, and the cloud providers do provide packet capture facilities, right, to do some pretty in-depth debug. But when you start turning these things on, you end up with a fire hose of data, for instance, landing on S3 on Amazon, right? And now you have to go through all of that data, and it's time consuming, it's difficult. And the kinds of tooling that we're talking about in this presentation today really allow customers to access that data very quickly. It's already managed for them by the tooling for both security and operational issues, right? So yeah, those are the kinds of things we see, and it's it kind of ties right into this kind of thing, right? When we look at these kind of service outages and poll people for what they're seeing, you can see here 45% of the issues are either dealing with network related outages or where we're consuming third-party services for some reason, right? So these are definitely the kinds of areas, 45% where this kind of tooling, the kind of products that cPacket and our security partners are providing, right, to deal with issues and operation.
Totally agree, Andy. Yeah. And I think this really kind of are the reasons, why there is a growing need for having an observability strategy, which is becoming more important for businesses now.
So by the way, to the audience, feel free to pop some questions in to us. We're happy to take those questions as we go along through the presentation. And we're curious about the kinds of outages that you may have seen. And if you want to raise those, either conceptually or specific examples, we can try to address some of those throughout the course of the presentation. All right, so moving right along. So in today's presentation, I'm going to be focused mainly on the cloud and cloud, network-centric observability, right? And of course, security, because that's the whole purpose of this summit. And so the things that we're going to be talking about today are kind of encompassed in this red circle here. But I also want to bring up the fact that a lot of organizations that are dealing with the cloud, they also have their own on-prem environments, either in their office spaces or in some cases for the larger organizations we deal with, they even have on-prem data centers. So what's really important to know is that you have to have a strategy that comprehends interoperability with your data center and on-prem tooling too. And so the kinds of products that cPacket and our security partners are developing, they interoperate across the hybrid environment, right? From the data center all the way to the cloud. So this involves traffic that is going over direct connects or VPN links to the cloud, the ability to look at traffic on both sides the hybrid environment, right? What's happening in the office or in the data center, and also compare that to what's happening in the cloud and be able to look at both sides of those transactions, right? And be able to monitor those as they move through the topology. So that's really important. So this anywhere, anytime, and real time are the three key messages we want to raise with people. But anyway, I'll be discussing mainly the cloud side. So talking about AWS, the three major clouds, AWS, Google, and Azure. All right, in this slide, I really want to lay the foundational basis for the rest of the presentation. And I'm going to talk a little bit about cPacket's products here. cPacket's cCloud solution has a variety of components. These blue boxes that you see in the middle of the diagram are cPacket's key virtual appliances that help capture the network traffic around the infrastructure and then bring that traffic into the right tools so that it can be analyzed, so that it can be indexed, so that it can be searched, and also so that it can be provided to security tools so that they can identify security issues that are happening in real time. And also something that we can't forget, and I'll get into later in the presentation, is the forensic use cases, right? So when new vulnerabilities are discovered, we have to be able to go back and look at a period of time in the past and be able to understand whether or not nodes were affected in the past, right? And you can do that with these, the tools and the approaches that we're going to talk about today. So just starting at the top of the diagram, there's a box, blue box labeled CVV. That's our packet broker. And there's two boxes labeled CVV. And the reason I have those two boxes for the same product is because they can operate in two different modes. They can operate in an inline mode where they're capturing traffic from around the infrastructure that is the production traffic. So the CView broker sits on the production traffic path. And then there's an out of band or endpoint mode where it's really just receiving mirrored copies of the packet from points of interest, workloads around the infrastructure through the cloud's packet mirroring or traffic mirroring facilities. So one involves being on the production data path, and the one involves being out of band, where it doesn't have any possibility of disrupting the production data path. But as we'll talk about later, there are some intricacies in both of these approaches, and which ones are better for security and which ones are better for operational incidents and debugging, right? So we'll get into that. The other message here is that if you look at these blue lines coming out of the packet broker, this is effectively how we're distributing the packets to downstream tools. So once the packet broker has received a packet on its capture interface, it then distributes the packets in real time to downstream tools, and it can make multiple copies of those. So we can have multiple downstream tools receiving the same packet streams. And down on the bottom right-hand corner of this diagram, we see that there's a set of purple boxes that represents the security tools. So those boxes are placeholders for security tools that work with real-time packet streams. Now, this is really important when you have multiple tools receiving packet streams. The existing features in the cloud, say traffic mirroring or the various load balancing solutions, they don't replicate traffic. So this is the key function of the the packet broker, is that it can create replicated copies of the packet streams and feed tools that have different purposes in life for handling those. On the bottom of the screen, there's a box labeled CStore V, and this is one of our own tools. It captures traffic from the broker. It stores it, indexes it, provides a search capability, which is really important, and it also provides protocol analytics. So all of these things together can be used for operational incidents, and in the security context can be used for accessing aggregated captures after the fact, historical data, right? So it might be a week or 2 weeks of data, depending on the sizing that's done for these deployments. The other thing I want to point out here in terms of the products is that they're designed for the cloud in terms of being managed as a sort of infrastructure as code, if you will. The configuration can be managed and the tooling is provided. There's a variety of tools to then deploy these things in clusters to operate in a highly available mode with the cloud provided load balancers. and then provide a level of redundancy too, so that so that the systems can be restacked occasionally, can be updated, and also handle various availability use cases, both across zone and within a single zone on the cloud. We'll get into more of that later. So the key message here is packet brokers are creating replicated real-time streams. The cStore product is capturing and storing the packets for forensic use cases for the security tools. All right, heading to the next slide. This is the next building block, if you will, on top of just understanding the virtual appliances. One thing to take note about the virtual appliances, this is a different approach than an agent-based approach. So with virtual appliances, you're building this fundamental building block that we have here in this diagram that's encapsulated with the blue line. We call it a monitoring network. That's just a term that we made up to host our tools, right? So this monitoring network is the fundamental sort of observability building block. This thing can be deployed in a centralized way on the infrastructure, but it can also be stamped out and deployed in a distributed way around the infrastructure at points of interest where separation of concerns is important, access to data by different users is important, and where network data may not be traversing, multiple networks. You may need to just capture it right as close to as possible to the source of the traffic. So this is an important concept to understand, and this is very different from an agent-based approach where agents are deployed alongside applications. Earlier, I mentioned that we have some customers with 3,000 VPCs and tens of thousands of nodes. So you can see where an agent-based approach becomes very difficult to manage in terms of thousands of nodes. And it isn't just the technical aspect of deploying agents to nodes. It's also the organizational dynamics, right? You have to now convince application owners in a variety of different organizations potentially to deploy those agents alongside the workloads. And of course, the agents may have performance impacts and resource impact on the nodes themselves. So this approach here, where we're creating an infrastructure that sits on top of the cloud infrastructure, right? An observability infrastructure that then deals with traffic as it moves through the infrastructure. This is a completely different approach to the agent-based approach. And it allows the IT and security teams to focus on caring and feeding for these tools in a much different way from the agent-based approach. So here we can see too, the purple boxes represent the pieces of the solution that touch on security. So just starting at the upper left-hand corner, let's talk about the firewall's relationship to this stuff. So usually what we see happening in our customer deployments is that firewalls both are doing two things. First of all, they're the first point of all traffic. So both internal and external, we see customers turning on firewalls, either the cloud provided firewall or a security vendor's firewall product designed for the cloud, where they want to have traffic around the organization always bounce through a firewall first before it takes the next hop. So usually what we're doing with our products and this observability solution is we're a next hop after the firewall. So once you understand how to set your firewall as a next hop, you can then take that same knowledge and turn on routing or the firewall configuration options to then forward the packets over to the monitoring solution on the monitoring network. Now, this is the load balancer that you see on the top of the diagram. So that's a cloud-provided load balancer. So it's a very, highly available cloud resource that the cloud providers themselves are providing and supporting. And then we're integrating with that. So we integrate with their health checks, and our appliances are deployed into those load balancer pools and are receiving the distributed traffic from the load balancer. Okay. And of course, once the CVV, our packet brokers, receive the traffic, it can then forward it down to the tools below, right? So this is what I touched on earlier. So those tools are receiving those real-time streams, and then the tools at the bottom can access APIs from our cClear and our cStore products to get the aggregated captures. So the important takeaway here is that you want to kind of think about how are you integrating with your firewalls? Are you going to take a distributed approach or a centralized approach in your infrastructure? And then how are you going to start building up the tooling around deploying these products and analyzing the results? All right, take a quick look at my notes here. Yeah, so we do see, actually, there's one other thing I wanted to add here. We do see customers building their own applications on top of APIs around these security tools. So what we've noticed is that the IT teams and the security teams that are deploying these, they then have to grant certain users and access to certain bits of data. So they'll often build tools that sit on top of this and then access the data just for what that user needs, right? And so they're doing that with some additional value-added applications. All right. Let's see, I'll head the next slide. So now that we understand that the notion of a monitoring network, right, you can see that in this slide, I'm kind of zooming out a little bit more, and I'm talking a little bit more about out-of-band and inline approaches. So you can see through the middle of the diagram here, I've stamped out a bunch of these monitoring networks and I've spread them around this hypothetical infrastructure. So let's just start looking at things on the left-hand side and focus our attention on these red lines. So the red lines throughout this diagram represent the production data path. Okay, so this is really the inline approach to capturing and inspecting the traffic as it moves around the network. This tends to be a great approach for security purposes because you are basically setting up routing and deploying your monitoring networks appropriately so that it can inspect the traffic, usually as close as possible, but sometimes in a centralized way to the sources, but it can inspect it as it moves through the network, right? So you don't really have to think about resizing the applications or any of the VM considerations or the workload considerations themselves. You can really focus on the network topology and how you want to get packets into the monitoring network. So if there's anything I can have you all take away from this is that this is obviously a simplified diagram, but the really important thing is as you start to think about this stuff is who are all of the people involved, right? The application owners, who owns the various networks, who are all the stakeholders that are going to be involved that have to somehow be involved in this design process, right? We've had some cases where we work with customers where they understand the solution at a technical level in terms of the security tools receiving packets, right? But what they often don't understand is that in order for the security tool at the very end of the pipe to receive those packets, there's a variety of other routing and topology decisions that have to be made. And in some cases, for some customers, there may be vendors involved that own different parts of the puzzle. So I've had customers where one vendor owns the direct connect link between an on-prem data center and the cloud, and another vendor owns some part of the cloud infrastructure. And all of these people sort of have to be involved in the process and the design process as early as possible. Otherwise, the deployment becomes complex and can be delayed, right? So this is a really key takeaway from this slide. So looking back at these red lines and in the center here, I'm kind of showing a centralized approach, right? So this traffic that's going from the red boxes in the upper left-hand corner through that centralized monitoring system and out to the internet and back. This is an example of supporting multiple zones with a load balancer as the first point of contact for the traffic coming from the VPCs. So a good example of this is Amazon's Gateway Load Balancer feature that we can integrate our tools with and be able to inspect all of the traffic coming through for both security and operations use cases. So looking at the right-hand side of this diagram, we see some blue lines coming out of the VMs. These blue lines represent out-of-band options. So this is the mirroring capabilities provided by the clouds, either packet mirroring, for instance, on Google Cloud or traffic mirroring on AWS. So these are probably not necessarily the best approaches for security. They can be used for security in some cases, but when you use traffic mirroring, what you also have to consider is the amount of bandwidth and how traffic is coming into the workloads themselves. And so there are side effects in terms of how traffic mirroring is implemented and how it splits up the traffic between the production bandwidth availability and the traffic mirroring availability on a particular node. So there is a possibility in this context for skipped packets on the mirror side, because often the VMs are going to favor, the network interfaces connected to these VMs are going to favor the production traffic path over the traffic mirroring path. So that's an important consideration, and it can be dealt with in terms of sizing the VMs correctly so they have enough bandwidth to handle the packet mirroring needs and the production traffic needs, but that adds additional complexity in terms of the application owners, right? So if the application owners are the IT team or the security team, that's probably just fine, right? But if they're not, that could introduce some complexity.
Hey, Andy, you just mentioned, AWS, and you mentioned, Google Cloud Platform. So does it also hold valid?
Yeah.
For,
so on
Microsoft
Azure, the approach at this moment in time is always an inline approach. So Azure doesn't currently have a publicly available packet mirroring or TAP solution at this moment. So on Azure, we're always dealing with an inline approach that really follows these red lines that represent the production traffic path. Yeah, but that's a great point, Kashif. Thanks for bringing that up. Alrighty, so this is the key here. Let's just go on to summary. So again, just thinking about the traffic, either out of band versus inline is really an important takeaway here, right? You should be thinking about how you're going to design your observability system or how you're going to retrofit your system for observability. The inline approaches are going to require you to think a lot about routing, where you put your load balancers, and then whether or not you take a distributed approach or a centralized approach, right? You want to understand, of course, as we just touched on with Kashif a second ago, which features your cloud provider offers. So I touched on Google and AWS in terms of the packet mirroring capabilities, and then Azure and AWS both provide options called gateway load balancers and also the standard load balancers, and also the routing capabilities to route packets through these monitoring networks. So you really want to dive into those kinds of features, user-defined routes on Azure, and then the routing configuration required for the gateway load balancer on AWS. These are the areas you want to be reading about and your teams thinking about in terms of deployment designs, right? When it comes to creating your visibility options, you want to think about how application owners and the infrastructure owners might be affected and which stakeholders are going to be needed to be involved, right? So often you might find some security solutions that you think can handle your needs, but you have to understand whether or not those security solutions require a packet broker in front of them, and often they do, and that's why we come into play, right? We work with the security providers to get the packets to them. You need to start thinking about that, right? And who's going to be involved with setting up those routing rules, dealing with data movement. By the way, another thing we see people do is they start small, right? They develop sandbox versions of these systems and they start running traffic through these. So that's a great way to get going and build a hands-on intuition, right? You can start generating small monitoring networks, and you can baby step your way in, bringing a little bit of traffic in or even simulating traffic. So I highly encourage people to think about that. And, you can contact both cPacket and our partners for, assistance in setting up these POC networks, if you will, right? The other big takeaway here, and this is what I see a lot, is that a lot of customers, they understand the technical features they need. They've even done maybe some of the design work that's required to get the packets. But then what they often forget about is all of the life cycle and support required after their solution is deployed. So I'm just going to head back a couple of slides here just to look at this one here. So when you deploy these virtual machines on your network, you need to be thinking about not only how they function, but also how you're going to restack them every so often. So we see customers who have, every so many weeks, they have a golden image, machine image that these things are launched from, and they relaunch them, right? They clean everything up and relaunch it so that they can avoid, any latent security issues that have, potentially infected these deployments, right? Of course, the same life cycle applies to getting upgrades. So all of the life cycle tooling that goes around these is something that, of course, we provide assistance with, but it tends to be something that's pretty specific to customers, right? So understanding how auto-scaling works, understanding how auto-scaling lifecycle hooks work, right? Understanding tools like Terraform and CloudFormation. These are all important bits to this, and they can't be forgotten once we actually get to getting closer to deployment. Let's see. Okay, I think I'm going to open it up for QA here. So feel free to ask any questions at this point, and Kashif is going to take care of the questions coming in. But I did want to pose a few polls to the audience. The first poll is an easy one. It's how far along are you with your cloud deployments? So we're trying to get an idea for the audience in terms of people just starting out, whether or not they're already in their proof of concept phases, or maybe testing certain deployments, or if they're fully operational, have scaled deployments, and now they need to add new support for security and operational observability. So we'll do that poll. Kashif, how's the questions at this point?
So, Andy, we do have a few questions from the audience, but I think let's go with the poll pretty quick, and then, we can go into the Q&A.
Okay. I'm watching it real time as it comes in. It looks like a lot of folks are just starting on their journey, so that's good. That's good to know. Hopefully that means that you'll be looking at, the design elements on one side, the stakeholders required, and then also the life cycle and management parts near the end. All right, I'm going to go ahead and we're going to do one more poll. Where do observability solutions currently reside in your organization? Is it the network operations team, security operations team, application teams, potentially? I'm guessing there are application teams deploying some sort of observability solutions. Or maybe the option is you don't have any observability at all right now other than what the cloud provider provides by default. Take a look at that. Kashif, how are the questions? Any Q&A coming in?
Yes, we do have some questions here, Andy. So I think we have the poll results.
Yeah, it looks like security ops teams are handling observability. Okay. That's great.
So Andy, I think we can get started with the Q&A. You can just bring the next slide here quickly. For the audience, we have some QR codes here. We have a QR code for our latest product literature, like cloud observability, collateral, cloud security collateral. Please scan this QR code, and you can download all the, the latest assets. You can also contact us for a demo, with one of our experts. You can scan that too. And then if you're looking for some specific security resources, technical briefs, solution briefs, data sheets, you can scan the last QR code here. So Andy, moving to the Q&A, right? So the first question coming from the audience is, what are some of the organizational and tooling challenges that you're seeing most with your
I would
customers?
say the biggest challenge we have in terms of tooling is auto scaling and lifecycle management. Once customers have come up with a deployment design. So I touched on this a little bit in the presentation. For instance, we have customers who have multi-zone deployments, and so they've deployed things to 2 or more availability zones or 2 availability zones in different regions, and they're using auto scaling and availability zones for a couple of different things. One is if anything happens to the machine instances, for instance, the packet broker or any of the tooling that are in the auto scale groups, if they fail for some reason, they have the lifecycle tooling there to then relaunch the instance, right? Relaunch a fresh instance and continue doing work, right? But then mixed in with that, they're also doing updates. So updating based on gold images and then updating using the multiple zones as a way to keep everything running. While turning one zone off, they can keep the other zone running, and they can do the updates in the first zone, for instance. So those are I think some of the most technically challenging pieces. And then they have to, once they get that down, they have to then set it up with tooling such as Terraform and a variety of other configuration management approaches to then stamp it out across the organization over time. So this is something that can't be ignored, right? You have to think about it as early as possible and start coming up with a plan, and then take baby steps towards deploying it in smaller contexts and expand it out over time.
Absolutely, Andy. Yep, totally agreed. One more question from the audience is, why is packet-based analytics important to observability strategy if I have network flows or APM?
This is good. So the reason is pretty straightforward. A lot of the advanced security vendors tools these days are working on real-time packet feeds. So there are a variety of security tools out there, right? And layers of security. And of course, security in depth requires that. But the kinds of tools that we're talking about here are ones that are looking at raw network traffic. And so they're quite a bit different than the application and sort of agent-based security solutions that are out there. These are looking for a variety. They're often based on AI and ML approaches and analytical approaches to looking at traffic, and they have a variety of traffic patterns they look at that indicate security issues on the network. And so that's why cPacket ends up being involved, right? Because we're the folks who provide the packets and the network expertise.
Thank you, Andy. One more question from the audience. Can you say a bit more about how the solution works with the new
I think I touched on some of
this.
this a little bit. Let's see, I'm going to jump to a slide here. So this is definitely diving into some of the nuts and bolts here. But let's just take a look at this diagram. I had a few of these cloud-specific diagrams and backups. So this diagram here is lifted right out of some of the AWS documentation. So this is an example of a very simplistic example of a topology. But if you were to go and read about the AWS Gateway Load Balancer, which is a fantastic feature in terms of inline packet inspection for both operations and security. The EC2 instances over here on the left, they're connected to this Gateway Load Balancer feature through this thing called a Gateway Load Balancer endpoint. So what you're doing here is you're adding the Gateway Load Balancer endpoints and a Gateway Load Balancer. And then to the right of the load balancer is where all of our security tools and our cPacket cCloud appliances are deployed. So this is excellent because you're really dealing with routing configuration to get the packets basically bounced through the gateway load balancer, and then in real time, these tools can inspect the traffic and then allow it to move on to its final destination. So one thing to note here that I didn't bring up in the presentation earlier was that the CVUV, the packet broker itself, is the only part of the system that's in the production data path. So everything else downstream of the CVV, the C-store and the security tools, these are all actually out of band in terms of the traffic pattern itself. So the CView immediately sends the packet on so that it can move on to its final destination. And then in parallel, these tools downstream can then process the packets and make decisions in terms of security. But they can do that in their own time. They're not actually disrupting the production traffic flow. So only a tiny bit of latency is introduced here. These tools can operate on their own time. But yeah, this in a nutshell, this is how the AWS Gateway Load Balancer solution looks. Yep.
Perfect, Andy. I believe we have one more question from the audience, maybe the last one. So how does the solution scale? So I believe cPacket solution. So how does cPacket solution scale as the amount of traffic on my network increases?
So I'll just go to this diagram for this. So you can imagine a scenario where, more and more of these VM boxes are being added to the network, right, over time. So in the inline case, the way the solution scales is by understanding the bandwidth and latency requirements at a coarse level for the workloads that are going to be sending packets through the monitoring network. Okay, so you get an idea for how much bandwidth is going to be under inspection, and then what you do is you size the deployment. So I'm just going to flip back to this. Each of these boxes represents a virtual machine, and on each cloud you can pick what machine type this thing can be deployed on, right? And the machine type defines the CPU, the memory, the storage bandwidth, and the network bandwidth available to the machine. So scale is both a combination of each individual machine type and then how many of these packet brokers you put behind the load balancer. Okay, so that's really all of that I just described is all kind of bucketed into what we call a sizing exercise. So as part of the design of the system, you really want to be doing a sizing exercise and then over time evaluating whether or not you've deployed the right sizes for your virtual machines. And then based on those sizes, you're using auto scaling to then launch the right number of instances to handle the traffic, right?
Got it, Andy. Thank you. So I think this is it in terms of the questions coming from the audience.
Okay.
Andy? So I believe we are at the end of our session. Andy, thank you so much for sharing your expert insights and walking us through some real-world deployment scenarios and why network observability is becoming so critical for security and incident response. Also, for the audience, thanks so much for attending today's webinar. We will be back soon with our next live webinar in October. Thank you again, and have a great day.
Thanks, everybody.
Bye-bye. Thank you.